common tutorial for GK. So this is physics lecture Tajuddin. We are discussing about continue the ray optics second topic. So in this topic we have to learn about the refraction through a prism, refraction expression for refractive index of prism, dispersion, angular dispersion, color of the sky, microscope, telescope, and Newtonian telescope, resolving power of microscope. So friends, let's begin. The first is about the refraction of light by prism. So prism having the triangular shape, it has the two refracting surface, and this is A is called angle of prism. This ray is incident ray, this ray is refracted ray, E is emergent ray. So when the light is passing from the prism, N and this is the normal, N2 is the normal, A is angle of prism, ABCD is the triangular shape of prism, this is base. These are the two refracting surface. So when the light passing from the prism first surface, it get refracted from rarer to denser medium. From denser to rarer medium, the ray is moving away from the normal. This is towards the normal, and the angle between this delta is angle of deviation. Delta is the angle of deviation. It is an angle between incident ray and emergent ray. The angle of deviation is nothing but it is an angle between incident ray and emergent ray, that is called angle of deviation. So prism having two refracting surface, by passing the light it get refract and we are getting seven colors, that is dispersion. So A is angle of prism. A is angle of prism. So let's see here. In this prism, when the light is passing, so after the solution, we are getting that I angle. The sum of I angle and emergent angle is equal to sum of A and delta. So here I is, this is the result we are getting by the seeing the refraction of light. So this is sum of angle of incident and angle of emergent is equal to sum of angle of prism and angle of deviation. What is angle of incident? It is an angle between incident ray and emergent ray. Uh, Angle of incident is angle between incident ray and normal. Angle of emergent is angle between normal and emergent ray. A is angle of prism. Delta, this is angle of minimum deviation. So sum of angle of incident, sum of angle of emergent is equal to sum of angle of prism and angle of deviation. Hope you understand this. So now move ahead. Variation is changing of angle of deviation, changing angle of deviation with angle of incident. Both are inversely proportional to each other. Angle of deviation is inversely proportional to angle of incident. What does it mean? as when the angle of is increases, the deviation angle is decreases. Yes. Now this is only this one. So Asaji is not recorded, it is a live class. No, it is an online class. So this is continuation of this one. Vinaji, it is not offline, it is an online class. Okay? It is not regarded, it is a live class, it is a continue class. Okay. So, well, once again, this continuation class of the optics welcome you all Raman tutorial for GK. So now we are discussing about variation of angle of deviation with angle of incident. As angle of incident is increases, the angle of deviation is decreases. At particular value of angle of incident, the deviation become minimum, that is maybe that is approximate 38 degree the angle of minimum deviation. At particular value of I, the D angle is become minimum when I is equal to emergent angle, and that minimum deviation, that particular angle when particular angle of I, the B angle is totally very less minimum. So that is called as the angle of minimum deviation. So after the minimum deviation, now I angle is gone increasing. So here refractive index of material of a prism, angle of prism is equal to refraction of 1, refraction of 2. So that both A is equal to 2R. So if we change this one, A we are keeping 2 is denominator. So this just now we got sum of this equal. So when angle of minimum deviation both are equal, no friends, today, yes, Asha ji, we will solve the numericals, we will solve the MCQ question also. Today is not holiday, today we are taking the class. Okay? Yes, we will help you, we will solve the numerical, we will solve the MCQ question. So R is equal to A by 2. This both are equal, so it is I is equal to angle of prism, angle of deviation divided by 2. This is for angle of incident. So now this is Snell's law. Refractive index is equal to sin I by sin R. The ratio of sin of angle of incident to sin of angle of refraction. As such, we are ready to help you. We will solve the problems and we will solve the MCQ questions. Okay, let me complete this first. After that, we will solve that one. It's not offline class, it is a continuation part of optics. So today is not holiday. So this is refractive index. Refractive index is sine angle of prism, angle of minimum deviation by 2 and sine A by 2. This is the important formula for refractive index for the prism, material prism. Based on this formula, they may ask the question in examination. Okay, friends. Today we are discussing about the optics, ray optics, second class. When the particular angle of incident, the angle of deviation become minimum, that is called minimum deviation. As I angle of incident increase, angle of deviation decreases. So this is the formula for refractive index of material for the prism. So friends, hope you understand this. Let's move ahead. Refraction of a light, bending of a light travel from one medium to another medium by a small angle of prism for a small angle of incident. So this is the Snell's law, and refractive index is equal to sin E by sin R2 is the emergent angle. This is refracted. I is assumed to be small. R1 and R2E will be very small. So by replacing the angle, we are getting this is the angle of deviation is angle of prism refractive index minus 1. This is the formula for angle of minimum deviation. So that just now we have learned this is the important formula for refractive index of prism, that is equal to sine angle of prism angle of minimum deviation by 2 upon sine angle of prism by 2. Now this is refraction by a small angle prism for a small angle of incident. This is for the formula is for minimum deviation. Now dispersion of light by the prism. When the light is passing from the prism, friends, we are welcoming you for the class of physics topic optics, continue second class, ray optics. Hope you understand this. Today now let's discuss about dispersion of white light from the prism. When the white light passing from the prism, how many colors we will get? So this dispersion we are seeing in nature, that is rainbow, we are getting 7 colors. So friends, just now we have learned reflection, refraction. Now we are discussing about the, yes, Akshataji, your answer is right. That is 7 colors. Already we learned reflection, refraction. Now we are discuss about the dispersion of light. If we pass the white light from the prism, how many colors we are getting? We are getting 7 colors. That is pure red, orange, yellow, green, blue, indigo, violet. The red color bending less. The violet color bending more. Refracted more. The light passing from it. This is the angle of prism. We are getting the 7 colors. Right. What is the reason for dispersion? Different color have different angle and they have different wavelength. The reason for dispersion of light, the different colors have different wavelength and they refracted at different angle, hence they get separated. All colors don't have the same wavelength, they have the different wavelength, they get refracted by different angle. So we are getting the 7 colors. In nature we are seeing the rainbow during the rainy season. Now the question is the prism is separating the color or white light made up of seven colors? The white light is made up of seven colors. If we are passing the red color, monochromatic light from the prism, if we pass the monochromatic light, will they separated into seven colors? Or will we will get the seven colors when we pass the red color or blue color? If friend you pass the blue color from the prism, how many colors we will get? If we pass the blue color, if we pass the only red color, how many colors we will get? The same we will get the seven colors or we will get the only one color. So friends, we will get only one color. Now see here, the refractive index of violet is greater than refractive index of red, and red color R is greater than violet. So refraction refraction of red color is greater than the violet. So after the here, let's just see here the colors separated with different angle of deviation. Violet is more deviated, red color is less deviated. Out of seven colors, yes, Akshita ji, your answer is right. Red color is deviated less. The violet color is deviated more. And each color have different wavelength and different velocity and bending with different color. That's why we are saying the seven colors, and splitting of light into seven colors is called as dispersion, and group of seven colors is called spectrum. Now about the let's have discuss about the angular dispersion. What is the meaning of angular dispersion? Angular dispersion means that the difference in deviation two colors in passing by prism gives the angular dispersion for the colors. So the angular dispersion is angle between emergent ray of two colors is called angle of dispersion. Angle between the two colors. Angle between the two colors is called angular dispersion. Also, it is the rate of change of angle of deviation. So that angular dispersion written as refractive index of violet minus refractive index of red into angle of prism. Now, let's discuss about the dispersive power of prism. The prism is splitting the light into seven colors because white light made up of seven colors. We are getting the seven colors. Now, what is the meaning of dispersive power? Hi friends, welcome you in Raman tutorial for GK. This is physics class. Just already we have completed the Ray 1 topic. Now this is the second class for the continuation for the ray optics. Next class we have to discuss about the ray optics. So what is dispersive power? Dispersive power of a material of a prism is defined as the ratio of angular prism to the mean deviation. The dispersive power is defined as the ratio of angular dispersion to the mean deviation produced by prism, that is called as and dispersive power. So where delta is the mean deviation, minimum deviation or mean deviation. So this is dispersive power omega can be written as that this, or we can say this one. So next is about the scattering of the light. Who explained the scattering of the light? What is scattering of the light? Which scientist got the Nobel Prize explain about the scattering of the light? The Indian scientist in the year. The Indian scientist in the year 1930. He got the Nobel Prize for the explaining about the effect and scattering of the light. Already we have learned three phenomena: reflection, refraction, dispersion. Now, yes, Chetraji. Which one here that is about dispersive power? Chetraji, that is dispersive power is nothing but it is dispersion per unit deviation. Dispersion per unit deviation, that is called as the dispersive power. That is Tyndall explain the Tyndall effect, and yes, that is explain about the scattering, and the C.V. Raman. C.V. Raman explain about the Raman effect. Tyndall also explain about the scattering of light by colloidal solution, and the Raman tell about why the sky is blue. So Raman come up with when he went to foreign country, saw the sky and he observed the sky is blue. Then he thinking and did the research and he explained about why the sky is blue because of the phenomena scattering of the light. Now, what is scattering of the light? Spreading of light in all direction. Spreading of light in all direction, that is called as scattering of the light. And in the at the time of sunrise and sunset, sun is appear to the reddish color, and the ocean water, the sky is blue because of the scattering of the light. So friends, when the light is passing from the molecule of atmosphere, the visible light more effective in scattering of shorter wavelength, that is the blue color, and the longer wavelength, that is the red color. The amount of scattering is inversely proportional to the wavelength. This was explained by the Freeland. He told that the amount of scattering, the scattering is depend upon the inversely proportional to the fourth power of wavelength. As the wavelength is more, scattering will be less. So red color is having longest wavelength is refracted, scattered less. The blue color have shorted wavelength, it scattered more. Why the sunrise and sunset is red color? During the sunrise and sunset, the light from the sun near the horizon passes a larger distance, and in the earth atmosphere than does the light receive from the sun overhead. The greater scattering of the blue color and reddish color appear during the sunrise and sunset. Friends, you observe that in the early morning when you get up, see the sky during the sunrise and sunset, what is the color of sun? That is red color. Because at the sunrise and sunset, the sun is near the horizon and the red color and the sun rays, red color is scattered less. The light travel little longer distance. Blue color is scattered away. The red color is scattered less. And red color refers to our eyes. That's why sunrise and sunset it's the red color. Because of scattering of the light by the colloidal particle, atmosphere particle, the sky is blue because sky has the many particles. When the light passes from the sky, get scattered due to the scattering of the light, inelastic scattering of the light by the colloidal particle, that sky appear to the blue color. When we look at the sky, the direction away from the sun, we receive scattered sunlight which is shorter wavelength, that is the blue color. The sky is characteristics of blue color because blue color have the shorter wavelength, scattered more, and blue color reaches to our eyes. Because of scattering of the light, skies appear to blue. Hope my friends you understand it. Now, what is microscope? What is microscope? Why do we use microscope? To see the microorganism, bacteria and germs. So micro means smaller. It is show the microscope. So it is which lens? It is convex lens. This is also convex lens. Now today we'll now learn. So you are asking about unit deviation. We have the unit for the dispersive power, refractive index don't have the unit. There's no unit for the deviation, that dispersive power and other things are there, student. So here about compound microscope. So uh, dispersive power, see here please. The definition of dispersive power. Chaitraji, the dispersive power. See here the ratio of angular dispersion for those two color to the mean deviation by the prism. This is the definition of dispersive power. the ratio of angular dispersion for, yes, sir. Hi, Sri Lakshmi ji. Hi, Chaitra ji. That is dispersive power now. Dispersive power is like this is only. Now, how many lens we are using here? Two lens. This is an objective. This is the eyepiece. This is the compound microscope used in the lab for blood test and or in chemist bio lab we are seeing the different specimen. It forms the magnifying image. So here left side we are keeping the object. The for that this image is forming here. This object image is forming here. But for the second lens, this image become an object, and because of this image act as an object for the second, that is called as the eyepiece. First lens is called objective, second is called eyepiece. This second image is act as an object, form the magnifying enlarged image in front of the lens, and that is A dash and B dash. So friends, this is our object distance, this is our image distance, this is the optical lens. So when the light in the left we are keeping the object, after the convergence refraction image is forming here. This is the image for the first lens. For the second lens, this image is act as an object and again magnify. So it is from the big image, big magnifying image. So this compound microscope is called as the magnifying the object. That common eyes cannot see the things that can be seen by the compound microscope. Use the two lenses, eyepiece and objectives. Because of so much magnification, whatever the things our eyes cannot see, we can see the magnifying image. So friends, compound microscope used to see the microorganism. Here they have the two convex lens. One convex lens is act as a objective, another is act as a eyepiece. We are keeping the object in front of the objective. By the eyepiece we can see the object. Because here is a refraction of the light, the I dash B dash is an image. This image is act as an object for the second lens. Because of the again refraction, they are forming the virtual larger image in front of the second lens. So we can see the magnifying image which is not possible to our eyes. This is the function of the compound microscope. Hope my friends you understood this. So now next, objective is a converging lens near to the object. Eyepiece is a converging lens through which final image is seen. Both of a short focal length of eyepiece is focal length of eyepiece is slightly greater than objective. Both focal length is short, but as compared to objective and eyepiece, hi friends, as compared to objective and eyepiece, focal length of eyepiece is slightly greater than the objective. Okay, now just now earlier class we have learned about magnification is the ratio of image distance to object distance. Now we are discuss about the angular magnification or magnifying power of compound microscope. Let's discuss about the magnifying power of compound microscope. Is defined as This is the beta, this is the alpha, these are the two angles. So the angular magnification or magnifying power is the ratio of angle suspended by the final image at the eye to the angle alpha suspended by the object seen directly at a least distance of distinct vision, that is the 25 centimeter. This is called as angular magnification. Angular magnification are the two angles suspended by the one angle is suspended by the final image at the eye, and the second angle is subtended by the one is eyepiece, another is object seen directly. So that ratio is called as हेलो मैं थोड़ी देर से आ रहा हूँ जरा दोस्त यहाँ से ऊपर करने हाँ ले क्लास में कर लेते हाँ ठीक सो फ्रेंड so now next we have to discuss about the telescope. So what is telescope, friends? Hi friends, welcome to Raman tutorial for GK. We are discussing about the physics ray optics part 2. Now we have to discuss about the astronomical telescope. Image is at infinity normal adjustment. So here there are the two lenses. An astronomical telescope is used to see the star. They are very far away. So study the star to observe the star. We are using the astronomical telescope. In this we have the two lenses. This is the one, this is the two. This lens is having, this is called as the objective, this is the eyepiece. As compared to these two lenses, objective have the focal length greater than the eyepiece. So when the light are passing from the first lens, they after converging meet form the image at particular point. If this image is act as an object for this lens and from the eyepiece they form the image at infinity, so we are able to see the object far away. Telescope we can see the object very far away, see the stars. In the telescope we have the two convex lens, both focal length are changed. One lens act as a object, second is act as a eyepiece. They have the different focal length. So we can observe the star, the image is forming at infinity. So magnifying bigger image is formed. So because of that, we are able to see the far object. So friends, hope you understand this. This is our astronomical telescope that was discovered by Galileo. It has the two convex lens, different focal length. Focal length of objective is greater than the eyepiece. Aperture or diameter of objective is larger. The aperture or diameter Why the diameter of objective is larger? Because it allows the more light to pass in it. Because of that, we can see the far object. It allows the more light to pass in it. So, friends, that was angular dispersion of microscope. Now it is angular dispersion of telescope. Angular magnification or magnifying power of telescope is the ratio of angle suspended by image at eye as through the telescope to angle subtended by object seen directly when both object and image at infinity. So this is the formula for angular magnification or magnifying power for telescope. Earlier it was for microscope. Microscope is used to see the small object, microparticles. Telescope is used to study the celestial object, very far object. Both cases we are using the convex lens of different focal length. One we use to see the microorganism, another is used to study the celestial object. Now, this is astronomical telescope image form at LDDB. So friends, here we have the convex lens and here is the convex lens. This is the objective, this is the eyepiece. The first light coming from infinity meet to the point. This is image act as an object for the second lens eyepiece. The rays after refraction pass the magnifying image. So this is a function about the astronomical telescope. Now about Newton discovered the telescope that is called as Newtonian telescope, that is reflecting telescope. In that astronomical telescope we use the convex lens. Now we are using the reflecting mirror, concave mirror and plane mirror. So it is based on refraction that compound with microscope we used to study the gems. Astronomical telescope based on the refraction of the light. Now this is Newtonian telescope for reflection of the light. So friends, instead of using the lens, we are using the mirror. This is the concave mirror and this is the plane mirror. When the light from the star, when the light from the star, when the light from the star are coming, after the this is concave mirror which Chakraji, they are asking about the question is they've given the Snell's law formula and asking about which light is. Based on this, they are asking about which is the lens formula. They are asking about identify the lens formula. They have given the formula. They have given about identify which one is the Snell's law, and they ask about which mirror is called dentist mirror. In a dispersion, which color is bending less? Or they are asked in exam question will be there in a astronomical telescope. Focal length of objective or eyepiece, which one is greater? The definition is magnification is minus or plus which image is there. So after completion of this strategy, we will discuss about the MCQ. We will solve the previous year question for HSTR. So you will get about the knowledge about the how the questions they ask in examination. Hope friends you understand this. This is Newton discovered the telescope, that is reflecting telescope. This is concave mirror. It is converge or divert the light. It is converge the light. And by the plane mirror, yes, I will tell you Chakraji. Yes. What is LLDV? Okay, that is about yes. 1 minute I will tell you. So this is about the Newton telescope. So friends, LLDV means least distance of distinct vision. Least distance of distinct vision. So LDDV, least distance of distinct vision, meaning is smallest distance of object or minimum distance of the object in front of the eyes that person can see the object clearly. This LDDV is 25 centimeter. If we close the object to our eyes, we are not able to see the anything below the 25 centimeter. So least distance of distinct vision is called as the LDDV. That value is 25 centimeter. Hope Chaitra ji you understand this. Now what is this? This is Newtonian telescope. Why do we use telescope? To study the star. This is earlier telescope was different. That is based on refraction. Now this telescope is based on reflection of light. So here how many mirrors we are using? Two mirrors we are using. One is concave, another is plane mirror. So it converts the light and it reflects the light by the eyepiece. The person can able to see the far away object. It is work on the process of reflecting of the light. So here magnifying power is focal length of an object to focal length of an eyepiece. The object and the eyepiece. So light is from the sun falling on that one, and after the reflection it is come to the eyepiece. So this is the magnifying power. So now let's discuss about the resolving power of microscope and resolving power of telescope. So very easy definition of resolving power of microscope. It is the reciprocal of distance. The resolving power of microscope. Resolving power of microscope is reciprocal of distance between two objects which can be just resolved when see through the microscope. The two things are there. How we can differentiate, how we can see that one. Resolving power of microscope is reciprocal of distance between two objects which can be just resolved, separated when they seen by the microscope. So the difference in the distance, resolving power is reciprocal of distance between two objects that can be written as Q into refractive index sine theta divided by wavelength. So here, my friends, omega, this lambda reverse why it is wavelength, mu is the refractive index, and theta is the angle of a cone of a light from one object, this one. So objective, this is the definition of resolving power of microscope. Now what is resolving power of telescope? So friends, thank you for cooperating and thrust belief on the Raman tutorial for GK. Any kind of the problem, and we are ready to help you. We will try to solve the MCQ and the numerical problems. So now let's discuss about the resolving power of telescope. Resolving power of telescope is nothing but it is a reciprocal of angular separation between the two objects whose image seen separately. So objective, the two objects are there, the angular separation of the two objects, two distance object whose image can be seen. That is called as the resolving power. So earlier it is I have written it is resolving power of microscope, it is the resolving power of telescope. So optics have the two branches, ray optics and wave optics. Regarding the ray optics, resolving power depend upon wavelength, diameter of objective, the diameter of the objective and the wavelength of the light. So friends, we have learned about refraction by the object and dispersion by the prism. We have discussed about the resolving power of microscope and telescope. We have learned two types of telescope. One is astronomical telescope and the reflecting telescope explained by the Newton. And we have today learned about the different topic, scattering of the light. So friends, hope you understand this. So thank you for just believe the cooperating to the Raman tutorial for GK. We are always happy to help you. Any kind of the help, we are ready to help you. So friends, once again I am revising the things. This topic is for the uh, 9, this is 10th and PUC. So this kind of the physics chapter, whatever syllabus is given for HSTR, we are asking about 10th and PUC also. So friends, this topic today we have completed refraction by prism, refractive index of prism, dispersion. So refraction means change the direction of light, bending of light travel from one medium to another medium. Refractive index is the ratio of speed of light in a vacuum to speed of light in a media. The dispersion, splitting of light into seven colors, that is the dispersion. Angular dispersion, dispersive power. The blue color of the sky because of the scattering of the light. Scattering is splitting of light in all direction. Once again, we are recapitulating the things. And red color of the sun is also because of scattering of the light during the sunrise and sunset. The light travel larger distance, totally blue color is scattered away. The red color reaches to our eyes, it is a red color. And danger signals. The danger signals also the red color because red color is scattered more or less. Red color is scattered less. The microscope having the two lenses, one is the eyepiece, another is the objective of the different focal length we are adjusting, and we are used this to see the micro particles in lab or in biolab or biology classes explaining all the things we are learning. Astronomical telescope normal adjustment. Astronomical telescope image at least distance of distinct vision. This is the value is 25 centimeter, the smallest distance in front of the eyes that can see the clear object. The telescope is used to study the stars, see the celestial object. This was explained, this discovered by the Galileo, and the Newton discovered the reflecting telescope. Instead of the using the lens, he used the concave mirror and the plane mirror and get the image. So we are last to discuss about the resolving power of microscope. फ्रेंड्स, धन्यवादಗಳು आप सबका शुक्रिया, आपने रामन ट्यूटोरियल फॉर जीके पे भरोसा किया है। हम आपको हर लिहाज से हेल्प करने के लिए रेडी हैं। आप अच्छे से तैयारी कीजिए, जो भी क्वेश्चन आएंगे उसको ध्यान से पढ़िए, प्रिपेयर करिए, एग्जाम में अच्छे से नंबर लाके आपको जल्द से जल्द, समय कम है, आप टाइम मैनेज कीजिए, आपको जॉब, गवर्नमेंट जॉब मिलेगा। एनी काइंड ऑफ द हेल्प फॉर द रामन ट्यूटोरियल, आप नंबर पे कॉल कीजिए। वी आर रेडी टू हेल्प फॉर गिव द नोट्स और एनीथिंग। सो वंस अगेन, the physics class today we are going to conclude. So next class we discuss about the next topic. The next class after the today is Sunday now. Next class is about on Tuesday. The next topic we'll discuss about on Tuesday. So till then, namaste, adab, sat sri akal. Thank you very much for the joining. Bye. Take care. Good night. All the best. Thank you very much.